Okay, my previous video got abruptly muted. So as I said earlier, here we have three decisions. Okay, what one is do not drill any well. Second is drill up to 200 feet, and third one is if no water is found at 200 feet, drill further up to 250 feet. So these are the three decision alternatives. The states of nature are water found and water not found. Those are the two states of nature, and the payoff here is the cost of drilling. Okay, the cost of drilling and the cost of procuring water in case if no water is found from the neighbor. Okay, so that figure is given to us already, 15,000. Now the cost per foot of drilling is 50 rupees. Okay, so this is a cost data. So what you should do is, once we have finished with the analysis, the EMV, the least EMV will be the optimal decision. Okay, so this is connected with the cost. The earlier problems we will be looking at the payoff in terms of profit. Okay, so we were trying to maximize it. So the maximum profit is the most optimal. Here it is the cost. So the minimum cost is the optimal solution. Okay. So our decisions will go this way. Okay, we do not drill any well, or we drill up to 200 feet. So once we get drill up to 200 feet, there are two outcomes we can get. Either we'll get water. Okay, so if we get water, the cost of drilling will be 200 rupees, 200 feet into 50 rupees per foot, that is 10,000. If there is no water, we take another decision. Okay, okay, D2, to drill up till 250 feet if there is no water. Okay, so if you drill 250 feet, either you'll get water or you'll get no water. Okay, so water, what you get is 250 into 50, so that is 12,500. If there is no water, 15,000 plus 250 into 50 for the cost of drilling, so that will be 27,500. If you do not drill after 200 feet, your cost will be 15,000 for procuring the water plus 10,000 for the cost of drilling till 200 feet, so 25,000 rupees. Okay, so at D2 decisions, we have two decisions to make. One is drilling up to 250 feet or do not drill. Okay, drill up to 250 feet, either you'll get water or you'll get no water. The probabilities are that you will get water is 20%. Okay, at 250 feet, the only 20% is stuck with water, and at 80% you will not get water. So the EMB for drilling is 12,500 is the payoff or the cost that you will be paying to get water, plus 27,500 for not getting water into the respective probability. So the expected payoff or the expected value is 24,500. Okay, EMV for do not drill is 25,000. There is no probability. So the EMV is smaller to act for the ACT drill up till 250 feet. So that is 24,500 is less than 25,000. So this is an optimal ACT. So here is the consideration that you should be focusing on. Okay, since this is related to cost, okay, the EMV that is minimum or the least is the optimal. Okay, so at D2 point, the decision will be to drill up till 250 feet. Okay, so the next one is D1. Okay, so at D1, either we drill or we do not drill. So the probability of finding water at 200 feet is 70%. Not finding water is 30%. So 10,000 into 0.7 plus 24,500. So that is the minimum EMV that we have taken for decision D2. Okay, so this and this is compared for the value here. Okay, so this is 24,500 and this is 10,000. So no water is 30%. With water is 70%. Okay, so you arrive at 14,350. Okay, so EMV for do not drill is 15,000. Okay, that is you're procuring water from the neighbor, and you're drilling 200 feet. The EMV is 14,350, which is minimum. Okay, So combining D1 and D2, the optimal strategy is to drill the well up to 200 feet. And if there is no water struck, drill further up to 250 feet. Okay. So that is the optimal decision. Okay. So this is the end of the problem. And this is how we arrive at the solution. Okay. So thank you, students. Thank you for your time.